Welcome back everyone to our solutions for the supervised learning project. In part 1 we're focusing on the data and the first part of the exploratory data analysis or EDA. Let's head to the notebook and get started. Okay, here I am at the notebook. I'm going to scroll down to part 0 where you just had to run these cells, run the imports, reading in the data, and then checking out the head of the data frame. And then after this we have part 1, which is just a quick data check, and I would recommend that you always do this with a new data frame that you're not familiar with. And it's just to call /df_info to get an idea of what columns you have available, what are their object types, etc. And here we can see we have around 7,000-ish rows. Lots of them, or essentially all of them, are not missing anything. You can see by comparing the number of entries versus the non-null numbers, and if they match up, it means you're not missing anything, although we'll double check that later on in this notebook. And you can see that the vast majority of these actual data types are objects or strings. And there's only a few numeric types, so that's a good indicator that we'll need to convert things into dummy variables later on. We can also run a quick statistical summary check, and this kind of leads to the idea that checking many columns will be categorical. To do this, simply say /df_describe and run this, and you'll see the numeric columns, whether or not someone's a senior citizen, monthly charges, total charges, and tenure. Keep in mind that if you take a look at the head of the data frame, senior citizen was actually just zeros and ones. So it doesn't make too much sense to take a look at things like the 25th percentile or the 75th percentile for that, because you can see here it was already just 0, 1 encoded. So senior citizen here, not a lot of information that you can actually glean from this, but we can see you have tenure, monthly charges, and total charges. And this is probably actually more useful information, where you can see the tenure in months goes from 1 month, 2 months, 3 months, and so on, up to a maximum of 72 months. And then we have total monthly charges and total charges. So what we're going to do now is move on to exploratory data analysis and complete these tasks. We want to first confirm that there really are no nan or null cell values, and we can do that with a simple df is NA or is null, both are okay, and then ask for the sum of these. And if you get zeros across all of this, it means you aren't missing any values, because recall is NA will return back booleans, true or false, and then you can sum those up where all the falses will be zeros and all the trues will be 1. So if you get any ones, that essentially tells you true, something is null for that particular feature column. We'll move on to the visualization aspects, and we want to first display the balance of the class labels. And recall, we're trying to predict that churn column, so we're going to do a count plot here. It should look something like this. What we'll do is we'll say sns.countPlot, and want my data to be a data frame, and x is equal to churn. Recall, for a count plot, it's just going to do a group by and then a count and display that visually. So I don't actually need to declare what my y is going to be, because that's going to be the same for count plot for any feature really. It's just counting up the number of instances. And you can also think of this as value counts. So when you run this, you should see something that looks like this. And keep in mind, if you actually wanted the numbers, another way to do this is to say df churn and then say value counts. Run that, and it will return back the number of no's and the number of yeses. This is slightly imbalanced, but it's nothing too extreme. Usually when you're dealing with a ratio of somewhere like 9:1 or 10:1 or something more extreme than that, then you really do have to worry about imbalanced classes. In this particular case, it is imbalanced, but not too extremely imbalanced. It really depends on how well the features are at predicting the classes to see if this will be an issue later on. So it's not something we directly need to deal with right now, but it is something, depending on your model's performance, that you may need to go and take a look back at. Whether you choose to edit the class weight parameter in your model call and set it to balance, where it adds weights to each particular data row to try to balance that out, or you can also do resampling of the less common class, like yes class here. Okay, so let's go ahead and move on. Next, what we're going to do is we'll explore the distribution of total charges between churn categories with a box plot or violin plot. And to do this, I will go ahead and use a violin plot. We'll say violin plot. Again, data is equal to df. And then x is equal to churn. In this case, I do want to compare the distribution. Recall, y in this case is going to have to be a continuous category, like total charges. Run that, and we can see the violin plot here. And the violin plot is nice because it shows us that whole distribution and kind of this box plot in the middle. But if you wanted, you could also just use box plot to see a similar idea of the information behind this. Next, what we'll do is move on. And now what we need to do is create a box plot showing the distribution of total charges per contract type. And we also want to add in hue coloring based on the churn class. So how do we actually do this? Well, we're going to say the following. We'll say df, actually we'll say SNS box plot first. Then we'll say data is equal to df. And in this case, y should again be equal to that total charges column. And then x, notice it's separated by month to month, 1 year, 2 year. That's the contract type, so that column is just contract. There it is. And then we have hue equal to churn. Okay, so we'll go ahead and run that, make sure it runs correctly. And there we have it, month to month, 1 year, 2 year. And if you want, you can edit this to make it look a little nicer. Just going to quickly do that here. You can say something like fig size is equal to something a little larger, maybe a 10 by 4. And usually when you make this larger, you want to up the DPI, make the image a little sharper. And then we can also notice that the legend is inside. Recall from our visualization lectures, you can always move this around by setting its location manually. We can say LOC is equal to something like 1.1 and then 0.5 here. Go ahead and run that, and you get this a nicer looking plot. Okay, so what do we actually see here? How do we interpret this plot? Well, I can see that the distribution of people who have turned or churned yes versus no is actually quite similar to month, versus the longer you stay on, the more charges you're getting for people who have actually churned, which is kind of interesting here. So how do we actually interpret this? Again, we want to be clear that month to month is a little harder to interpret because it's very likely that if somebody is signing up for a month-to-month service, they're doing that because they don't expect to be on the service for a long time. So that's kind of a harder problem to fix as far as churn, because the customer could just come with the expectation that they are going to churn eventually, maybe after a few months, and that's the whole reason they're getting a month-to-month service. However, what about people that sign a 1-year contract or a 2-year contract? Is there something we can think of there to try to reduce churn? And this is actually a very telling plot, because notice the difference here in the distributions. When you're looking at a 1-year contract and you're comparing people that did churn versus people that did not churn, it looks like people who did churn are having overall higher total charges than people that did not churn. And it's the exact same thing for the 2-year contract. And notice here, it's even more extreme of a difference between the distribution of people who had more total charges that did churn versus people that did not churn had usually lower total charges, which is kind of interesting. So essentially what that means is after 1-year or 2-year contracts, people are more likely to churn if they're having more total charge. So we have to look deeper at the data and deeper at the customer segmentation to decide what's actually happening here. And is there a way we can possibly maybe have a reduction bonus after a 1-year contract or a 2-year contract, where we bring down those charges again to make sure that customer doesn't churn. So clearly, this is a good idea business-wise to say, hey, maybe we should start looking at some sort of coupon program after a 1-year contract or a 2-year contract. Because just based off these box plots, I can see that if the customer has more total charges, they're more likely to churn even after the 1-year or 2-year longer contract segments, rather than charging them less and having them stay on. Because if we're able to keep that customer for longer, we can get a more amount of money from them in the long run versus trying to squeeze more money out of them over 1 year and then having them churn. Okay, so lots of interesting things to discuss there. We'll go ahead and move on. Okay, the next task was to create a bar plot showing the correlation of the following features to the class label. So we have a wide variety of features here, and the class label is that churn column. However, keep in mind that for these categorical features, we're going to need to convert them into dummy variables first, since we can't calculate the correlation from a string to a number. Instead, all of these will have to be 0s and 1s before we actually calculate the correlation to the churn column. And you should also keep in mind that currently the churn column is hard-coded as yes or no. So that also needs to be converted to a dummy variable, 0s and 1s. Lots of different ways we can do that, but at the end, what we do want is something that looks like this. Essentially, the feature names and then their actual correlation to, in this case, yes churn, or churn being equal to 1, depending on how you define it. So there are a ton of different ways you can do this. We kind of show the simplest way in the solutions notebook, casting everything to a dummy variable, calling correlation on it, and then just putting the bar plot. So I'm going to show you that first, and then I can also explain some other methodologies for trying to create something similar. So let's come back up here. What we're going to do in this code is essentially set up our dummy variables. So we're going to say pd get dummies, and then I'm going to pass in all of these guys. So pass in this giant list here. And what I could also do is write in this same command, say churn, and then also say after this dummy variables. So notice if I just run this, it's going to create dummy variables for all these. So let me just run this to show you what it looks like real quick. So you run that, scroll back up to see the results, and essentially everything has been converted into a dummy variable. Notice senior citizen doesn't actually change because it was already zeros and ones, so it keeps it the same, zeros and ones. The other thing to notice is that I'm not saying drop first is equal to true. So you would see gender female as ones and zeros, and gender male as zeros and ones. Now, is this okay for the purpose of a visualization? Technically, yes. It would show you the correlation of gender female to churn versus something like correlation of gender male. And keep in mind, this information of gender male is technically already encoded in gender female, since if gender female is 1, then gender male is 0. But for the sake of visualization, it's sometimes easier to read the same information separately, so you can think about female versus male, or partner no versus partner yes, etc. Now, it's obviously not the case for certain machine learning models. In that case, you would have to say something like drop first is equal to true in order to avoid multi-collinearity and what's known as the dummy variable trap. So we talked about that previously in the linear regression lecture. But for right now, for the sake of visualization, this is technically okay. I'll leave it up to you if you want to drop that feature or drop first. And if we scroll all the way to the right, there is something we do have to think about. And that's the fact that we have churn no and churn yes. So we'll have to think if it makes sense to have correlations for both churn no and churn yes. Since we're really specifically trying to make a bar plot, we'd have to choose one of these. We'd have to say how correlated they are to not churning or how correlated they are to yes churning, since that's going to be the main correlation value. So if we come back up here, notice we chose feature correlation to yes churn. And if you did feature correlation to no churn, you'd pretty much get this inverted. So let's come back up here and figure this out. So I have all these dummy variables set up. What I could do is right after this call .corr to grab the correlation. And if you run that, come back up here, you should see now the correlations between all these variety of features. And if you scroll all the way to the right or scroll all the way to the bottom, you now see the correlation between all the features and churn yes. And recall, I'm kind of really only interested in the correlation of all the features to churn yes. So I will just grab the churn yes column. So if we scroll all the way to the right here, you'll see the churn yes column. So off of this, at the end here, I'm going to grab churn yes. But let's go ahead and just set this up as a variable so we can kind of understand the variables a little easier. So we're going to say pd get dummies on all of those. If you want, you can drop first, depending on how you want to interpret that. And then at the end, we have churn, calculate the correlations between all of them, and set that up as our core data frame. So we'll go ahead and hit enter there. And now I have this core data frame. And then what I'm going to do is just grab that churn yes column. So that's churn underscore yes. So run that, and you should see a series looking like this. So senior citizen, gender female, gender male, etc. And now what I'm going to do is I'm going to sort these values. So I'm going to say sort values. Because it's a series, I don't actually need to pass in a column name. So I'll say sort values, and I can scroll up here, and we can see churn no has a direct -1 correlation with churn yes. That makes a lot of sense because it's essentially the encoding of the reverse. And if you scroll all the way down, you should see, let me clear this cell, you should see churn yes perfectly correlated with itself. And for the sake of the plot, I don't actually care to say churn yes is 100% correlated to churn yes, and churn no is -100% correlated to churn yes. So those aren't very useful. So let's drop the first value or the first row and also drop the last row. How can I do that? It's quite easy with .iloc. I can do it with slicing. I can say starting at index 1, that's this index, contract to year, contract no or churn no is index 0. Then say go all the way up to -1, which would say go up to, but not including -1, which is churn yes. So that should bring us up to contract month to month. And this is just Python slicing. This is the same slicing we would use on a normal Python list, for example. So again, it's saying go to index 1 and then go up to and not including index at -1. So that's essentially saying don't include the first row and don't include the last row. And when you run this, you should see those results. So now it starts at contract 2 year, and then we scroll all the way down here, and notice it's starting at contract month to month. So let's set this up as our new values to plot. So we'll call this core yes churn is equal to grabbing churn yes, sorting those values, and then only grabbing 1 up to -1, dropping those churn yes and churn no rows. So now we have something we can easily plot out. So I can say SNS bar plot, where my x is going to be equal to core yes churn. And in this case, I want the x to be equal to those index, which is the feature names. And then y is simply going to be equal to the value. So I can say y is equal to core yes churn. And if I want, I can pass in those values, which are the numbers themselves. So if we just run this, we should see the results we expect. And there you have it. So we have the bar plot, and then we kind of have this mess of the x ticks, but it is looking like what we're expecting. We should probably rotate those x ticks to make it look nicer. So we'll say PLT x ticks rotation is equal to 90 degrees. Run that and go ahead and put a semicolon if you don't want to see the output of all the text. And that's starting to look a little nicer. Last thing you should probably do here is make the figure a little larger. PLT figure fig size is equal to something like 10 by 4 and up the DPI a little bit. And run that, and now you see this really nice plot. Okay, so we can see what's highly correlated with churning with yes. And just to clarify, I can also add in a title to this figure. I can say PLT title, feature correlation with yes churn, with actually churning. There we go. So what's highly correlated with somebody churning? If they're on a contract month to month, that's highly correlated with churning. It makes sense because if someone's signing up for a month-to-month contract, they're probably not in it for the long haul and do plan on eventually ending the service. So what's not correlated with yes churn? Well, it's pretty much the exact opposite. Contract for 2 year. If you're locked into a 2-year contract, it's highly unlikely you're going to break your contract within those 2 years. So that's going to be less amount of people actually churning. So it makes sense that we have this direct contradiction between contract 2 year and contract month to month. And here is where you can explore and dive deeper into the data for your own exploratory data analysis and visualizations on all the other features and trying to understand that. Okay, so that's the scope of our exploratory data analysis before we move on to part 3, churn analysis. I would encourage you to take any other visualizations you want to perform on the features and check them out yourself. But for this analysis, we'll go ahead and end it here and move on to a churn analysis where we focus on people that churn and creating cohorts. I'll see you at the next lecture.